Good morning, good afternoon, and good evening to you all. Thank you for joining us live at Pivot 2022. My name is Philip Bour. I'm the Chief of Geothermal Innovation at CATF's Superhot Rock Energy team. It's my pleasure today to moderate this session. This is session 2 of the Superhot Moonshot. Where are we headed? Session 1 just wrapped up and was moderated by my colleague, Bruce Hill, and was a look back at the successes and the results of international drilling efforts to drill into superhot rock conditions over the last 20 or 30 years. Bruce and his panel discussed projects from Italy with the Scramble, Iceland with IDDP, Mexico with GEMEX, and Japan with the Beyond Brittle project. This session, we're going to discuss how superhot rock has the potential to transform the global energy system, and how are we going to get there? Questions such as, how can we build on the learnings of the past projects? What are the gaps and barriers that we're facing today? And how can we get to our first successful demonstration? The topics that we'd like to cover and introduce you to the innovation that is going on within the superhot rock realm. Firstly, there's a lot of information attached to this session. If you haven't seen it already, there is a handout section attached to our panel, and there's lots of information there, papers, questionnaire information that my panel have kindly filled out and is posted up there for you to review and download. It's an excellent resource, along with other reports coming from CATF or HERO projects. And I encourage you to look at those resources. Secondly, there will be a Q&A session following an initial roundtable discussion. So please feel free to submit your questions and we'll try to tackle those. Thirdly, and most importantly, I'd like to introduce my wonderful panel and introduce them to the stage. Please join me in welcoming Igor Kocis, the Chief Executive of GA Drilling, Daniel Bour, the owner of Bour Consulting, Trenton Cladouhos, VP of Resource at Cyrq Energy, and Taylor Mattie, the Geothermal Innovations Leader at Baker Hughes. Welcome, gentlemen, and thank you for joining me today. I'd like to give you each a quick minute or two to introduce yourselves and what it is that you're doing for your respective organizations. So I'll start off with Trenton, please.
Great. First, thanks, Philip and CATF for inviting me to join this great panel. As a way of introduction, I'm a structural geologist with a career focused on fluid flow and fractured rocks. I've been in the geothermal business for 14 years. I'm a VP of Resource at Cyrq Energy. We have 6 operating power plants, including Hudson Ranch and the Salton Sea, which has wells above 300 degrees C producing. We also have new hydrothermal projects in various stages of development. Cyrq is primarily a conventional geothermal developer, but is supportive of an all of the above approach to geothermal, any way that we can, generate electricity. We have partnerships with EGS and AGS companies as a way to provide risk mitigation at our existing fields and promote technology development. I'm on this panel primarily because prior to Cyrq, I was at Ultra Rock Energy, where I managed the geophysical and geologic aspects of the Newberry EGS demonstration project. And when that project was completed in 2016, I led the pivot to Superhot EGS at Newberry. And that dream is now gaining much greater traction with increased interest and investment in all types of geothermal. And so that's why I'm really excited to be part of this continued progress.
Thank you. Daniel, could I jump to you next?
Sure. Daniel Bour, appreciate the opportunity to be part of this panel. My background is I'm a subject matter expert in well cementing. I've got 25 years with a major service company where I worked in their technology and technology development group, and then moved to field operations. So I've got a fair amount of field experience as well, knowing how things are actually implemented. I then moved to work for a couple geothermal startup companies and worked in production enhancement and well construction, obviously in the cementing side of things. I've recently been working in consulting business, first for a major consulting firm in Houston. Now I've got my own consulting firm where I focus on a variety of geothermal projects, including closed loop. Also do some work in the oil and gas business where I keep sharp on what's the latest technology. So again, great to be here.
Thank you, Daniel. Taylor, next, please.
Hey, well, thanks for the introduction. So my primary directive is to develop and execute the technology and innovation strategy for Baker Hughes in the geothermal space. I'm really excited to be here representing Baker Hughes because Superhot Rock is an area that we are also keenly interested in. And we participate in this on a global level by developing super high temperature hardware for drilling bits, but then also software for reservoir modeling and risk mitigation before we get to the expensive CapEx parts of these project development, which is drilling, right? And that's been a topic that we've talked about, or that was talked about in the last panel, and I'm sure it's gonna be talked about quite a bit in this one as well. So thank you, very happy to be here.
Thank you, Taylor. And then Igor, please, could you introduce yourself?
Hello, I'm Igor Kocis. I'm honored to be part of the panel that everybody is helping to geothermal from some different angle. Hopefully that will be successful together. My background is technology. We are coming from the side of the new drilling technology and approaches that can significantly make the geothermal drilling cost-effective, cheaper, being able to access the deep depths. What we said in the GA drilling as a main target 10 years ago, when it was really a scientific more approach, was to develop the new system that will be able to drill in a high pressure, high temperature, deep depths, very ductile environment in the future, being able to reach the depths that are much deeper even as of today. But on the other hand, we are now focusing last 2-3 years more in this engineering part to combine and integrate existing conventional approach with something that we developed in our also very high-tech test facilities, testing these harsh environments. And currently we are in the phase that we are trying this year and beginning next year to integrate it with existing infrastructure, being able to test it in a real wells in Houston, and trying to be the partner of the projects in the next couple of years to show that superhot geothermal is a reality, is not just some future dream in a science. So glad to be here and talk later.
Thank you, Igor. So thank you, everybody. I'm very humbled to be moderating a session with such experts, and I think one of the key things we hope to deliver is actually educate the public along with us. And so let's get started, and let's jump right in. I think Bruce in the previous session defined superhot rock as drilling into rocks greater than 374 degrees and on a high level of about 20 bars. So quite high pressures, high temperatures. I've heard many people comment, why try a moonshot? Isn't it too expensive? When rather, should we be focusing on incremental or other low-hanging fruit? So this is an open question to kick us off. Who would like to go first, please?
Sure, I'll go. So I don't know that we do need to focus. I think there's a lot of opportunity in geothermal. There are companies working on conventional expansions like Cyrq, Ormat, others. There's companies working on closed loop geothermal, and then there's also companies and projects working to try a hydraulic fracking at 200 degrees C. And I think we really ought to be doing kind of all of the above, pushing the limits of geothermal, pushing technology development, and I think Superhot Rock has got to be part of that because it's part of a long-term strategy for geothermal to do EGS or geothermal anywhere.
Yeah, and I'll add to echo that. It's if we get this right, and there's a lot of initiatives going on with it, it's not just Superhot Rock, right? The technology that's developed, the capabilities, the processes that come out of enabling a scalable version of Superhot Rock have positive impact on all of the other types of geothermal, right? Conventional hydrothermal, EGS, AGS, because the problems are a lot of the same, right? It's about how to drill and how to build wells cheaper and more cost effectively, and how to be able to control and mitigate the risks that come with different types of geothermal development. So there's a lot of similarities and a lot of benefits. This is just the really forefront of it and the most extreme version of geothermal that there is out there.
Yeah, I'd like to add to that. When I first saw the word moonshot, I thought that was a bit of an exaggeration. I think it's more like a high altitude, flight. We're not that far away from it, really. I'm working on a number of projects that we're essentially there already, and we're looking at the critical issues. So, yeah, I don't think we're that far away from it. And I think the next steps have to be just going out and doing it. I mean, you can only learn so much by studying it. You can't learn really how to water ski by reading a book. You've got to go out and do it. That's a bit of a stretch for an analogy, but I think the next steps, we have to go out and see what those challenges are, because we think we've got a lot of them at least addressed.
Yeah, maybe I agree with the predecessors totally, because I think it is not about something that we can show in 10 years that is this ultra super solution. It's important to know it and important to define it where we want to go in some long-term roadmap. But for us, it's also important what we adopted in our strategy, very similar approach, that we want to show, first of all, the results in the next couple of months and years that is viable. You can extend on the temperatures, you can extend on the conditions, but specifically what is important in general for the geothermal is to show the future scalability and today realistic solution that we can deliver to the market. And that, I think, is top priority, that through this step-by-step approach, we can, first of all, to attract the industry, talking about the energy industry, utility, to consider the Superhot geothermal as a real story. But in the meantime, to show the projects that can prove that, yes, the pathway is set correctly.
Mm-hmm. Great. Thank you, guys. I'm going to pick up on a couple of themes that came out of your comments. Scalable. How is Superhot Rock scalable, and what is important about its scalability? I think, Taylor, you mentioned the term scalable. If I could start with you.
Sure. Yeah. I mean, there's areas around the world that we're well familiar with that have easier accessibility to the resources that you'd consider super hot rock, like Iceland, coastal California, coastal US, where Ultrarock is doing different work there too. The idea of scalability is, how do we take that and move it geographically to regions that might not have the ease of accessibility? And so typically that means drilling deeper, right? And how do you create wells that are able to access these resources and aren't going to be a serious or put up a serious barrier to entry in terms of CapEx? And so that's really a technology play, right? And I'd want to almost pass it to Igor here to talk about what his tech is doing, because that's really the core of what they're looking to do with drilling deeper at a linear CapEx rate rather than the exponential CapEx rate that you get when you start to go deeper.
Yeah, go ahead, Igor.
Glad to elaborate on that a little bit, because I absolutely agree. That's why we also started our journey many years ago as a solitaires. It was when the geothermal was really in some very niche environment and not too much buzz like it is today, what is great, I think. And here, what we've seen clearly, that people basically and energy business, they didn't believe into geothermal, that it's something that can play the significant role. You can see it also in many strategies from the governments, European Union, US, that they underestimate the potential of geothermal, because we are not able to talk clearly that what is the real potential of that to be the part of the future strategic plans. And this is something that we want to change through the way that we can present the clear pathway and the technologies that can bring the scale. For me, it means that the deep geothermal should not happen only in a few places when typically are not living people, there are no industries. We need to bring this energy when it's needed means, first of all, to retrofit the big coal power plants, retrofit the old fossil industry. And it is, I think, the absolutely unique chance for the geothermal to step into that. And regarding the technology, what we were trying to do since beginning was the ability to define the clear drilling mechanisms using thermal, but also combined thermal mechanical way of drilling. We are using, for example, in our case, is a hot plasma that can destroy the rock, create the fractures, and then make it easier the whole drilling process to crumble the rock, to go faster, when today is a showstopper regarding the cost of the drilling, and being able to prove it in depths that are relevant to 7+ kilometers. Talking about 7-10 kilometers, there is no showstopper in the future. But what we decided a few years ago, that also the whole infrastructure should be prepared to go this way. I compare it, maybe even can learn from some other industrial-like comparison to the electric cars, for example. If you come 20 years ago with Tesla car, you have no place to plug in. You have at home the Tesla, and you should charge it only in your garage maybe. And that's a similar, if you have a great technology that can drill with some new ways, basically you cannot find then the rigs and the projects that you can enter. So that's, I think, very important to go. We call it also like a hybrid approach, that we are trying to utilize as much as possible from today's industry, from the rigs that are there, from the trained people that are there, and step by step in the next months and years to be able to go through the first successful results and then to extend it to new and new areas. So first of all, what I see as the next step is to focus on the projects that are between 5 to 7 kilometers, that also here some of my colleagues are involved. That will be super if we can find the way in next 2 years to make the tests, being able to show that yes, we can decrease the capexes on the side of the subsurface creation, and then build on that to extend these possibilities in the near future, really to the depths that we can scale them to the other areas that today we consider cold. Because this is, I think, the game change that we should show, that yes, in these colder areas, the deep geothermal could play the key role in the future and can be one-to-one retrofit potential to the fossil fuel plants, mostly today talking about the coal.
And I'll add to that just real quick on how to achieve scalability on the technology side, is it's not just the individual discrete elements of a well construction that are being worked on and improved that will make a difference. It's also the integration of the technologies that are used in the execution, right? So, the bits plus the directional measuring technology, plus the fluids and different techniques and processes, all operating as an integrated system that ultimately result in a reduction of the daily average drilling costs, right? And anything that can be done to reduce the number of days that a rig would be on site is significant when it comes to reducing those barriers for CapEx and the costs associated with it. And that's something that we've been working on quite a bit with our strategies, integrating the various aspects of well construction together, which is a technique that we ported from oil and gas and are deploying it in geothermal, and then taking it beyond to also include the surface equipment too. So, steam turbines and ORCs, and the software and digital elements of it for, the geothermal field of the future, utilizing Superhot Rock.
Taylor, that's great. We're unpacking an awful lot of topics here. I want to bring Daniel in, because you, in the conversation so far, and in the first session, drilling mud, cementation came up as key. Taylor, you just mentioned fluids in the well. I thought you inferred drilling muds there. Daniel, what can you talk about cementation, well completion, drilling mud? Where are the innovations going? What do we need to do?
So actually, to back it up, the comment I would make is I think we've got a lot of the solutions. Often the focus is on, we need a new cement that's either cheaper or works better, but actually the real problems that happen in field operations is the implementation, the placement of the cements. Often there's troubling or difficult problems of lost circulation. We have techniques to overcome them. There's also problems of getting a full column of cement from top to bottom completely set up. We've got techniques like reverse circulation. So actually the number one problem is just getting the materials that we know will work in place in the difficult drilling conditions. And I've seen in the past where not enough attention was played on the planning stages of some of the operations. And then we went back after kind of bruising our noses a little bit in some projects. We went back and did the proper planning and were able to execute with the existing materials we had. So focus on in the cementing is placement. And then some other issues have to do with CO2 resistant. There's technologies out there to address that. Another big issue is mechanical durability. It's, 3,000 PSI sounds like it's a great cement, but it may not actually hold up to the cyclic stress loading. Maybe a lower strength, lower Young's modulus cement would be more ductile and be able to absorb the cyclic loading. So you need to focus second, I think, on mechanical properties. And then I think lastly, maybe newer or cheaper cements. But actually another strategy that I think affects CapEx that maybe people don't think of originally is anytime you go out with a new technology, it's critical that you're successful the first time. So I think actually planning on investing maybe even double the amount that you would expect to pay to drill your future wells is well worth the investment to ensure that you're successful. And what happens with oil and gas drilling would be the same with geothermal. Once you're able to do multiple well projects in a given area, you can greatly reduce the cost of the wells using basically the same materials, but you just become more proficient. You can drive down costs once you get a baseline as much as 30 to 50%. And that has a huge impact on the overall CapEx of a project. So getting a project successful and then doing projects where you require multiple 10 plus wells on a project can greatly help reduce the cost.
Super. And Trenton, I want to pick up on a topic that was introduced earlier. Igor suggested that drilling in conditions shallower than 7 kilometers could kick off the Superhot Rock revolution. Where you provided a number of papers that are attached to our profile today. How do we find these locations, and where would you consider are the best locations today?
So yeah, and I agree with kind of everything that Daniel just said about drilling. You got to, and an important part of the drilling is when you're doing that, success also needs to be defined by learning, right? So you can't just have your success being a well that produces geothermal fluids. You're always got to be learning. As far as places, so I think obviously I've got a bias towards Newberry. There's a large thermal anomaly there that's conductive outside of the resource or the national monument. That could probably power half of Oregon if we can find a way to extract that heat. And I think probably, and we can hit that heat at 4 kilometers. There are a lot of places in the Western U.S., the entire Cascade Arc, COSO, it's been mentioned already, the geysers, where we can really kick things off, like Igor said about the Superhot. So we can solve how to create permeability and produce supercritical fluids or superheated steam, whatever we're going to use. And then, and actually globally, there's many places too. I mean, obviously Italy is one of those places, Asia as well, East Asia. Then we can start to worry about going below 7 kilometers once the energy drilling has succeeded, and then really start to expand. But I think we'll keep ourselves quite busy with the magmatic arcs and all those markets to begin.
Yeah.
And once the drilling's ready, we'll know how to do everything else, I think, at the shallower depths.
Yeah, I would like to add to that. There's a lot of existing geothermal fields where they have areas where we could just drill deeper and intersect. And then you have all the infrastructure for actually utilizing the production you get. So there's a great reduction in CapEx. So, I mean, we could greatly add thousands of megawatts to existing geothermal fields and do it at a greatly reduced cost, and then gain, as Trenton said, the expertise to show that we can actually do this and we understand all the mechanics and the drilling issues, and then go deeper. So that to me would be the normal series of events that would happen to get to deeper wells.
And just to kind of hammer that home, I guess, is there are many geothermal fields currently operating that are under capacity. So, and we know the heat's there. So, you know,
Yeah.
1 or 2 super hot wells at one of those places could bring them up to capacity or well beyond it. And leverage all that infrastructure that's already there.
Yeah.
Taylor, I've heard you talk in the past about Baker Hughes being able to develop greenfield and brownfield sites. Is there anything you'd like to add here about the technologies that Baker Hughes are adopting?
Yeah. I mean, there's a lot of different aspects, right? So I mentioned the hardware and the software side. So we're actively looking at technology that, you know, is rated for 300C, and this is something that we had done before in the past, right? So we had developed the industry's first all-metal mud motor that was developed for IDDP2 2017. We developed 300C drilling bits, and then we also had developed a 300C MWD systems as well. So it's been proven that there is, you know, the capabilities for that technology to operate in these conditions and be able to provide the same sort of expectations for risk mitigation, directional drilling, you know, reduction of invisible loss time, non-productive time with Superhot Rock, right? A lot of the focus that we put as well these days in the software side is on mitigating the risk up front, right? So that means careful planning, careful reservoir analysis, because everything that you could do to reduce the issues that you might see in the project execution and the uncertainty of in the reservoir before getting the rig on site is critical to mitigating the execution risk that Daniel was talking about before, right? Not having something on site is a horrible thing to happen because it costs money, right? You know, $50,000 to $60,000 a day is what you lose if you are unprepared with certain aspects when you're drilling really deep. The one element too that's worth noting is we had invested into a company recently called Greenfire Energy, right? And it seems like the term closed loop is a buzzword, a pivot so far already. So I'll talk a little bit about that. And one of the ways that we are working with them and utilizing it, both for conventional hydrothermal and also for Superhot Rock, is risk mitigation in the execution of projects, right? So in the event that you drill and you miss whatever your target is in terms of production from an aqueous reservoir, the systems that Greenfire has are almost like a physical insurance barrier that you can have. So you're able to use those to still extract heat from the well, regardless if you have that naturally occurring flow to the surface or not. So it's a real holistic stance of how can we mitigate the risk in the well construction, in the production, and in the upfront reservoir analysis, geophysical analysis, and work together to build that system in order to eventually get to this point of scalability. The last thing that I'll add too is this isn't something that we could do alone, right? Superhot Rock, much like other aspects of geothermal development, it requires partnerships, right? It requires the industry working together in all different aspects of it, both on a micro scale, individual demonstrations, but also on a macro scale when it comes to communicating the value of Superhot Rock and communicating the value to the greater society who really have no idea what geothermal is and what the ability is to extract the heat beneath our feet for clean energy that's sustainable and baseload. So we put a really broad emphasis on working with the industry, partnering with them for technology development, for execution, for social campaigns, and that's really what's needed for geothermal to become something out of the shadows and into the forefront, especially with regards to Superhot Rock.
Great. I want to bring Igor in on the discussion of drilling. Rates of learning, Igor. We've seen them innovate quite quickly in oil and gas and drop the costs. Can you talk a bit more about GA's innovation and how you can reduce the cost of drilling? Drilling being one of the major capex issues for Superhot Rock.
Yeah, like these are these two parts already mentioned. That one what we see is let's say technology approach that you can significantly decrease or let's say increase the rate of penetration, increase the lifetime of the drill bit. That is our main task. But on the other hand, what is also extremely important, I see this learning curve that Daniel, I think he talked about that of course first projects they should be subsidized. Doesn't matter if it will be more also from some grants or from the private investors, typically operators that can help in the first one or two such kind of wells or the projects. But what we see, this campaign approach could be the huge difference. What we expect also in our solution, that you can relatively easy, learning from the shale gas development last 10 years in the US, and this ability to decrease the cost even up to 70% and more. That's something what we see as an ideal solution for the deep geothermal, because if you take the deep geothermal project in the future, you have the one place, and in one place you will drill several very deep wells. So the drilling company can spend months and years basically on one site without need to move around and look for some other places. And you can get so much data, information, optimization from the place that this another wells, I'm talking about third, fourth wells, and so on, a campaign could be very different price, and not only due to the drilling, but due to the whole chain of the activities that you have to do there. And that's something what I think is really reasonable to be able to predict what does it mean to make such kind of successful project, and how then you can, let's make it easy, copy paste such kind of projects to the other customers. Because exactly as was also here before, people don't know exactly what does it mean, the hot or deep geothermal, and we should show them, first of all, what does it mean in number of or size of the gigawatts or future terawatts, what can bring the industry to today's hungry industry business. And second is the viable way forward, that if we are able to do successfully one or two projects, what I agree, absolute ideal way is to go through the brownfield. It means through the project that already is the geothermal activity, is the there are the data, there is the experience to do the first showcases there, but then be able to also propose to the energy industry the other places that were not today considered as suitable geothermal places, and then basically make the copy paste in these places. But what we can expect, the price would be significantly lower due to the many reasons than in the end for the scale up. And in the end, what we should present are the electrons, or the ability to bring the LCOE in the way that in 5-10 years, it will be one of the best baseload energy that this industry can show, and to be the part of the real energy plans of the society. And that's, I think, is a common work that all these companies around that today we are trying to work, is to jointly to show this potential and to convince the right people that it is worth to spend now for the pilot supporting.
Very nice. I want to go back to a topic we haven't fully addressed yet, and that is the question of open loop versus closed loop. We've talked a little bit about these terms. I'm going to ask Daniel to kick us off. Particularly, what are the differences in completions? And then after completions, I think I'd like to talk about reservoir. So if that helps you, Daniel.
Sure. There's generally, when you say closed loop, you're just drilling a hole in the ground and you're circulating water either in one well and out another, or in the same well down an annulus and up an insulated tubing string, extracting the heat. And the challenge is extracting the heat out of stingy rock that doesn't have very high thermal conductivity. So there's a variety of strategies. Some of them are pretty proprietary that I can't go into detail on, but strategies to make it more than just a one-dimensional equation. And those things are being actively worked on. I know a variety of companies doing that. But the idea is you eliminate some of the other associated risks with trying to produce fluid either through fractures in the rock that are created, or existing fractures at the higher temperatures. So it's a trade-off in risk. There's some risk reduction in the area of completion, because you can drill these things anywhere, a closed loop system, but then there's the challenge of heat production, which makes it a different problem that has to be solved.
Great.
I'll kind of comment on that. So I think I agree with Daniel that it's kind of a much different risk profile doing closed loop versus open loop. And by changing that risk profile, maybe moving more of it to drilling away from reservoir development, what you lose is a lot of the advantages that I see of Superhot, at least, which is this high energy per well and very high energy density. So closed loop, you might drill into 400-degree rock, C, but produce 200 C water. So it's, you know, it's much more like a conventional system at that point rather than Superhot. You're mining Superhot rock, but you're not producing Superhot fluids. Definitely reservoir development or kind of creation and operations is going to be difficult. There's no doubt about that. But we do have the model of hydraulic fracking from oil and gas. I think it's going to be quite different than that when we start to try it in the field and do further laboratory testing, how we create that permeability. But I think we can, and I think that's something we need to, get on trying to do, is create the open EGS reservoirs, because that's, to me, that's the real breakthrough. I'm supportive of closed loop because I think they are going to really develop the drilling and the completion for all of us, and possibly we'll see that work as well. But it is a different risk profile for sure.
Yeah, and any work done in either area is going to be complementary. Just like you're saying, hey, if we learn something in closed loop, that'll be applicable. A lot of it, at least, will be applicable in Superhot EGS system.
My comment only shortly to the closed loop is that definitely I see the closed loop as one of the ideal solutions in the areas when it's very hard to predict also the geology, and being very independent on the rock type. On the other hand, what is the challenge here, that the capex, or the cost of the creation of the closed loop, mainly caused by the number of the wells that you have to drill, is very high. So here I see also, that's what we studied in the past, that for a closed loop you have to significantly decrease the overall cost of the well drilling and completion to be able to have such enough number of the wells that you can talk about the high megawatts or even gigawatts in the future compared to the open loops today. So fingers crossed to all these projects that will be successful.
I think, and I'll add to what everyone's saying here, I completely agree with. The one aspect that could be advantageous to look at is how to hybridize project development that is combined closed loop and artisanal production, right? So if you're looking at a project that has 5 wells, the exploration well could be planned as a closed loop well, where with that you sustain your economics and the capex with the closed loop in the beginning, but you use that exploration well to get a good idea of what the fracture network looks like, what the reservoir looks like, and then from there you could adjust the plan for the future wells, either with different methods of stimulation, EGS, hydroshearing, or the directions of the wells, or it could be an idea of that might be the project itself, right? If it's not successful in any capacity. So it's a way to look at how to develop these projects differently, and not just on an individual well basis, but systematically.
Super. Right, we've got 2 minutes before we move to a break, and before we go to open Q&A. We've got, in that short time, let's pick on one question here. What is the key innovation needed for a successful demonstration? If you could each choose your top innovation need. Taylor, why don't we start with you? You're on camera.
It's a difficult one, right? Because there's a lot of different aspects of how to reduce cost, and in my opinion, Superhot rock is a cost thing, and as a function of that is technology, right? So what technology is it? Hard to say, right? My philosophy and the philosophy that we are bringing to the market from Baker Hughes is integration, right? Take incremental technology changes in the bits, in the fluids, in the cementing, and the processes, combine them all into one integrated system to reduce the cost a little bit here, a little bit there, and throughout the entire process, rather than developing some widget that is able to just take care of it all at once, right? So I can't really hammer down on one specific technology, but it definitely needs to be a combination of incremental step changes through the bits and through the system itself.
Right. We will pick up with Igor on that same question when we come back from the break. Thank you, everyone.
Thanks.
Thank you.
Thank you.